Hello everybody and welcome to my channel. In this video let's take a look at a new proposal for Swift 5.3 that adds a new set of functionalities to the standard library. So currently the standard library has a specific type, which is the range type, to describe a set of values in a contiguous manner. So we can, for example, describe that we want a contiguous set of integers for 1 to 100. And this, as you can see, it doesn't create the whole set of numbers. That will be insane, imagine for big ranges. But it has a specific type that describes the lower bound and the upper bound. Now, what we can do is actually create an array from numbers 1 to 100, and this indeed now it's gonna allocate all the memory to have all these numbers already there. It's not a range anymore, we are working with the array of numbers. So as you can see, the standard library provides already some functionality to work with a contiguous set of numbers. And there are more APIs to work with ranges. For example, one interesting one is that you can remove the subrange that goes to the 50 number, and then you get an array that only has the rest. So the standard library has APIs to work with this, a contiguous set of values. What it doesn't have is a way to describe non-contiguous set of values. So this is what this proposal tries to solve, and if you are used to working with Objective-C or with Foundation, you already know that there is a way to do that in that library, which is the index set. The problem with index set is that only works with integers, so it's not a generic container like where we are used to work with Swift. That's why the standard library has introduced this new type, which is a range set. One nice thing about this proposal is that even if it has been accepted, the status is really not implemented in the standard library itself. What they did is they are using this new standard library preview to offer us the opportunity to start using these new APIs without compromising already the standard library. So they can polish it and improve it, and when everything is ready, then we can have a proper introduction of these APIs into the language itself, and then yes, we need to compromise forever until a new API breaking change to keep it supporting these APIs. So it's really nice that we can take a look before it's super official and we need to have them forever. So I have a project here with this new type imported, and let's play a little bit with it to see what it can do. It's important to understand that the range set is generic and it can contain any set of ranges that are bound to comparable types. But it's, of course, the main purpose is to deal with collections. Like, for example, you can keep track of the selection on a list that the user has done, like multiple selections. Or, for example, if you are using a search and filters, you can keep track of indices to remove what the user has indicated and whatnot. So it's a really powerful type that it's generic over any range that is comparable, but the main purpose is actually to work with collections. Let's take a look at what this type can do on itself. So one thing that is interesting to understand from the get-go is that it may seem like this thing is just an array of ranges, but it's not as simple as that. It's actually a smart type that understands what a range is and how the ranges differ between themselves, the space that there are between the ranges that you add, and all that stuff. So let's explore a little bit the API that it offers to manipulate the ranges and see how it actually doesn't affect the result as if it was an array of ranges. So let's create a range set with a couple of ranges. So we have a range from 0 to 5 not included, and 10 to 15. Now, what will happen if we add into this range, we insert another range, which it doesn't have any real numbers in it. Like, for example, if we go from 7 to 7 without including any new number, we haven't added any new range really. So the set is understanding that, and as you can see, the output hasn't changed. We can do the same, for example, adding a range that it's already included in some of the ranges that we have. For example, if we include the range from 1 to 3, for example, not included, you can also see that there is no change here because it's also inside here, so we don't have to do anything with it. Also, if you add a range that expands an existing range, for example, if we go from 11 to 20, it doesn't add a new range, it actually knows which one you're affecting and it's expanding it. You see that now we go from 10 to 20 instead of just to 15. And even more, if we add a range that crosses from one range to another, for example, a range that goes from 4 to 15, it understands that the two ranges that we had separated before, now they are contiguous and they are one. So it merges them in one that goes from 0 to 20. That it's quite nice. It's a super nice way to work with a non-contiguous set of values, and the API makes sense, the decision that it's taking, it all makes sense. So this was just to prove you that it's not just an array of ranges, it's actually much more than that. Let's see what other capabilities it has. For example, it has APIs that are similar to the set algebra APIs. Doesn't include them all, but you can have, for example, a contains to check if this number is in there. For example, if we ask for 6, it should tell us that it's false because 6 is not in this range. But if we ask for 2, it should tell us that that's true because it's actually part of this range. But it has more things, like, for example, we can ask if this is a subset of another range that, I don't know, that includes 1 to 3, and I don't know, 6 to 10, for example. And that's gonna do the set algebra operations to actually check that if this set of ranges, it's a subset of the other set of ranges. And we have the typical algebra operations like set is superset, subset, it's a symmetric difference, and all that kind of stuff, unions, and everything we're used to from set operations. This RangeSet, of course, has access to them. Something that you don't see on the API, but it's curious and it's interesting to know, it's been discussed on the forums and the implementation of it, it's that the RangeSet is generic, but it has a specific implementations for the commonly known types. Like, for example, if you have a RangeSet of integers, we know the size of those types explicitly, so the standard library, it will include some specific performance optimizations in terms of specific storage implementations for this known set of types. This is really nice, but let's now take a look at how this plays together with actually what we want, which is have more capabilities and better APIs on the Swift collection types. So let's create an array, as we did before, that goes, I don't know, to 50 this time. So we have here an array of 50 elements. Now let's see what APIs have been introduced into the collection types. We can, for example, get a range set that includes all the elements on the array that match a specific predicate that we want. For example, let's take a look at the indices of even numbers. And for that, we can just get the number and we can ask for the subrange, and these are the new APIs where, and then we can use also this recent API. So we can see here how we have a set of ranges, including the indices of any element in the array that actually matches this predicate. Just for fancies, we can see how we can shuffle the array, and maybe we get a different contiguous set of ranges. For example, we can see that here we went from 8 to 10, from 29 to 32, so you can see how like there is actually ranges. It's not just giving you every index possible, it's actually giving you the ranges. If we probably increase this to like a bigger number, we probably have a higher chance of having even numbers consequently. You can see that we went from 80 to 85 because all those numbers were even. So that's quite nice. Now that we have a range of indices, so again, this is not an array of the elements of the array, these are the indices that we can find the elements that conform to this predicate. We can actually take the numbers and subscript into them with this RangeSet directly. So we're gonna perform an operations, like we can probably like null this, for example, or I don't know, or add 1. We can do whatever we want directly into the numbers that we found with this index. So we don't have to go one by one or a range by range. We can actually use the range set directly to subscript into the array. For example, we could use the reduce to start at 0 and add the results. And we probably want to print this again. And there you go. You have an addition of the numbers that are even on this set of elements. Let's go to a smaller set. And let's, for example, do something else that it's quite useful in many times. For example, when you're working with a UI that it's a list and the user can select multiple rows that don't have to be consecutive rows, and you want to move them and stuff like that. You want to perform, for example, an operation that moves the subranges from one place to the other. And this is also something that this helps with. We can get the indices, in this case, that match this predicate, but you can imagine that you were creating these indices from the interactions of the user on the screen. You can put them, for example, at the start of the array. And you can see now how we have the even numbers at the start, even if we shuffled everything. So that's all I wanted to show you for this proposal. Again, it's very nice because you can go yourself and pull the preview package and play with it on your real applications and give some feedback to the standard library folks to improve it before it's officially part of the standard library. If you learn anything with this, please like the video and subscribe for more content like this. Thank you all for watching and see you next time.